Welcome to This Explainer. I am absolutely thrilled you're here with us today. Right now, literally as we speak, massive data centers all across the globe and right here in the United States are humming away. They're quietly processing billions of data points to optimize the traffic lights in your city, the supply chain of your local grocery store, and even the exact bandwidth needed to stream This Explainer right to your screen. Today, we're jumping straight into the nuts and bolts of artificial intelligence. We're moving way past the theoretical stuff. Instead, we're exploring the tangible, everyday infrastructure derived from our source material. We're going to track how the underlying architecture of simple home smart devices scales all the way up to advanced medical diagnostics that are, no joke, actively redefining modern healthcare.
Okay, let's dive into this. How many times have you actually interacted with AI today? Take a second to really think about it. The source material presents a fascinating, honestly kind of staggering reality. The average connected user triggers hundreds of background AI inferences before they even finish their morning coffee. We're not just talking about the obvious stuff, like asking your smart speaker for the weather. It's the invisible stuff. The API calls. It's the spam filter instantly routing your emails. Or dynamic pricing algorithms adjusting your rideshare fare based on real-time driver density. It's even that biometric scan that unlocked your phone in a fraction of a second. We operate within this incredibly intricate web of predictive models, and peeling back the onion on how these models silently harvest and interpret our behavioral data, well, that is absolutely crucial for anyone navigating today's digital ecosystem.
Which brings us to Section 1. AI is already here, and we need to shatter the illusion right now that this is some futuristic sci-fi concept.
The source hits the nail on the head with this quote. AI is no longer a distant dream. It's our present reality. That right there anchors the entire analysis, and it's a huge paradigm shift. For decades, the public conversation around AI was totally bottlenecked by sci-fi imagery, sentient humanoids, futuristic dystopias, all that movie stuff. But the source makes it incredibly clear that true AI integration doesn't look like a robot handing you a plate of eggs for breakfast. It looks like silent, ubiquitous infrastructure. Our present reality is built on these mind-blowing advancements in compute power and cloud architecture. Over the last decade, we've shifted from isolated static databases to dynamic, interconnected server clusters that can process vast oceans of unstructured data in real time. This invisible infrastructure is literally running global financial grids right now. It's optimizing complex logistics pipelines and managing global telecommunications. The tech is firmly established, it's heavily capitalized, and it is fundamentally interwoven into the economic backbone of our daily reality.
Moving on to Section 2, how AI actually learns. Now, what's really interesting about this slide is how it guides us right into the invisible mechanics of the technology.
Let's break down this highly complex architecture into two fundamental, easily digestible steps: learning and adapting. When the source material talks about Step 1, AI learns, it's talking about gobbling up massive datasets mapped into multidimensional vector spaces. See, an AI model doesn't understand a photo of a cat or a paragraph of text like you or I do. Instead, it relies on complex neural networks to translate all that data into mathematical weights and parameters. It's hunting for statistical patterns, correlations, and anomalies across billions of data points. Then we hit Step 2, AI adapts, and this is where the engineering is just brilliant. Through processes like reinforcement learning and backpropagation, the system continuously observes and adjusts. When the model makes a prediction and gets feedback, maybe you correct an error or you click a recommended link, the system dynamically tweaks its internal math to get better next time. It's a relentless, automated cycle of statistical optimization. The system is always refining its parameters to shrink the margin of error, building a highly customized output based entirely on your evolving data inputs.
So let's look at Section 3, AI in daily life. Let's take all that abstract machine learning we just talked about and bring it right into our tangible, relatable reality.
We're talking about smart assistants like Alexa, shopping, and entertainment. And this brilliantly illustrates the sheer omnipresence of AI in our mundane daily routines. These platforms are essentially just the front-end user interfaces for massive machine learning models. Take entertainment, for example. When a streaming app queues up the absolute perfect movie for your Friday night couch session, that's not magic. That's collaborative filtering. The algorithm is comparing your super specific viewing habits, literally down to the exact timestamp where you paused or gave up on a show, against millions of other users with similar behavioral clusters. In e-commerce, shopping algorithms analyze micro-behaviors, like dwell time, how many milliseconds you hover your mouse over a product image before scrolling past. Now sure, the adaptation isn't always perfect. I mean, we've all had that hilarious glitch where you buy one single plunger online and suddenly the algorithm is aggressively recommending plunger accessories for the next month, acting like you're starting a collection. But despite those little hiccups, the sheer volume of data being processed ensures these systems get eerily accurate at predicting what we want, seamlessly embedding themselves right into the fabric of our daily lives.
That brings us to Section 4, the future of AI. We are pivoting away from this low-stakes consumer tech to look at what the future holds for some incredibly high-stakes applications on the horizon.
Let's move to and see how this builds a really powerful contrast. On one side, we have the everyday convenience of asking Alexa a question. But on the other side, we have the profound, life-altering potential of advanced medical diagnostics. We're seeing the exact same foundational mechanics, that pattern recognition and statistical optimization we talked about earlier, make a massive leap. A system trained to figure out your grocery preferences relies on the exact same underlying mathematical principles as a system trained to literally save lives. The source material highlights oncology as a prime example here. Researchers are deploying convolutional neural networks to analyze radiology scans. These AI models are trained on millions of historical images, learning to spot pixel-level anomalies. We're talking about microcalcifications in breast tissue or tiny geometric irregularities in lung scans that are completely invisible to the human eye. They can flag potential malignancies years earlier than a human radiologist ever could. And think about it, the algorithm doesn't get eye fatigue at the end of a 14-hour shift. It processes scan number 1000 with the exact same rigorous mathematical precision as scan number 1. We are witnessing a rapid, breathtaking transition from algorithms that just make life easier to sophisticated models with true life-altering diagnostic capabilities.
And this brings us right to the core thesis of the source material. AI is actively shaping the future of our reality. This is why this matters so much. It's not just a cool technological upgrade, it is a fundamental societal and economic shift. By moving from reactive systems to predictive ones, AI completely alters how we allocate resources on a macro scale. Right now, predictive models are being deployed to forecast energy grid consumption, to optimize agricultural yields based on tiny climate fluctuations, and even predict urban traffic patterns to cut down on emissions. When a technology can learn and adapt at a superhuman scale like that, it stops being just a handy tool we pick up every now and then. It becomes the invisible scaffolding of modern civilization. The societal implications here are just vast, pointing us toward a future where our civic, economic, and even biological systems are continuously monitored, managed, and optimized by machine intelligence.
So as AI continues to learn and adapt, what part of your reality will it shape next? There's this fascinating, almost philosophical feedback loop happening here. These systems learn exclusively from the data we generate. That means human behavior shapes the algorithm. But as those algorithms adapt and start curating our information, our medical treatments, and our daily choices, the algorithm inevitably starts shaping human behavior right back. It's a continuous symbiotic loop of learning and adapting. So as you navigate the invisible digital infrastructure of your day-to-day, keep that feedback loop in mind. Ask yourself not just how the technology is serving you, but how its predictive models are subtly defining the very boundaries of your digital and physical reality. Thanks for joining us for this explainer, and we'll catch you next time.